any object moves with constant speed in a straight line, unless it's acted upon by an outside agent. That fundamental principle is called the law of inertia.
Heavy objects naturally fell toward the center of the Earth, because that was the center of the universe. If the Earth really is spinning and hurtling through space, why doesn't everything fly off? And if the Earth really is spinning, why should an object dropped from a tower land directly below? Why doesn't it land in the next city-state or at least some distance away? Contrary to both Aristotle and the doctrine of the Church, was the Earth merely another planet orbiting around the sun? If that were true, the question remained, why in the world doesn't everything spin off? Galileo realized that a ball, after rolling down one inclined plane, would roll up another until it regained its original height, no matter what the steepness of the second plane was. If the incline of the second plane was shallower, the ball would roll farther along, not stopping until it was as far above the horizontal as it had been at the start. The more nearly the second plane was horizontal, the farther the ball would roll, trying to regain its original height. Therefore, on a perfectly horizontal plane with a smooth surface, a ball would never come to rest. It would keep rolling forever. This was the crucial realization that Galileo needed to explain why everything, including his critics, could keep up with the spinning surface of the Earth. A body in horizontal motion tends to keep moving that way forever. But everything on the surface of the Earth is in horizontal motion at exactly the same speed as the surface of the Earth itself. There's not even any friction to affect a body's motion, because everything moves together. René Descartes straightened everything out, giving the law of inertia its final shape. Objects in motion don't tend by themselves to come to rest. They tend to continue as they are until something interferes. How does the idea of rest fit into this grand scheme of things? It doesn't. Nothing in the universe comes to rest. Instead, anything and everything will continue to move as it is in a straight line at a constant speed until something interferes with it. That's the principle of inertia. Obviously, objects can seem to be at rest, but that's only because they're in the same state of motion as the viewer. Whether an object is at rest or in motion depends completely on viewpoint, on whether the observer's moving right along at the same speed. Absolute rest does not exist. Absolute motion does not exist. Even hurtling through space at an incredible speed, relative to the moon or the sun or the center of the galaxy, the natural tendency of any object is to retain whatever motion it has. This coasting object will keep moving until the brakes, or something else, brings it to a state of rest. But what about an object that's not just moving horizontally along with the surface of the Earth? What about a projectile launched into the air? Or a ball dropped from a tower? Shouldn't the spinning Earth leave the falling ball behind? Galileo said it shouldn't. He said the ball should continue to move horizontally with the Earth, even as it falls vertically toward its surface. In the Renaissance, this concept was as hard to grasp as quicksilver. So Galileo offered his contemporaries an analogy. An Aristotelian observer would have no doubt at all about what should happen. The ball should fall directly toward the center of the Earth, while the ship sails out from under it. That sailor on deck would see the ball hurtle toward the rear of the ship rather than fall to the foot of the mast. Though the experiment was probably never performed during Galileo's life, the results are precisely what he predicted. The ball falls straight down along the mast. The ball falls along the mast because both objects, ball and sailboat, share the same initial motion. If they don't share the same initial motion, then the result is just as the Aristotelians would have expected. But when dropped from the moving mast, the ball falls vertically while moving horizontally with the boat. Together, these motions form a curved path, a parabola. Galileo realized that these same principles would cause the motion of any projectile to follow a parabolic curve, whether at sea or on land. A ball dropped anywhere on the surface of the spinning Earth behaves the same. Here, sharing the horizontal motion of the planet, it falls straight downward and lands at the base of the tower. In these terms, Galileo saw and proved something new under the sun.
Hidden within the law of inertia is the fact that all motion is relative. Whether a body is in motion or at rest depends strictly on the point of view of the observer.